Okay, so uh, the next thing, so another example that we're going to solve under this product rule is a case whereby the product rule is a function of like three functions. It's product of three functions. So if y equals to say x plus 1, x squared plus 1 into bracket x. So x into bracket x plus 1 into bracket x squared plus 1. So that is a product of three functions. So how are you going to differentiate this? So you're still going to apply just like the same wisdom that you use in the case of two functions. So what you're going to do is this. If y is product of three functions, so then the y dx, so that is the case of this is like if y equals to u v w, so then the y dx will be equals to u v the w dx plus u w the v dx plus vw du dx. So the meaning of this is that, so you pick these two, you differentiate this. Look at this. So you pick the first two, you differentiate the third one. So then you pick the first and the last, you differentiate the second one, you differentiate v. Then you pick v and w, you differentiate the u dx. It just means that you differentiate all of them while picking the rest of the two. So I hope you've gotten that. So in this case now we have y to be equals x into bracket x plus 1, x squared plus 1. So our x is the u, x plus 1 is the v, x squared plus 1 is the w. So now we're going to differentiate this. So it implies that we have uv. So if this is our u and this is our v, you pick the first two. uv x into bracket x plus 1, the w dx. So that means you're going to differentiate this. So the derivative of x squared, that's what? 2x plus the derivative of 1 is 0. So you move plus so plus we have uw. So this is u, this is w plus x into bracket x squared plus 1 uw. So the v the x. So where's our v? This is our v. So you differentiate your v. Differentiate your v. What's the derivative of x? 1. What's the derivative of 1? 0. So then we have plus so plus what? vw. So what's our, where is our v? X plus 1. Where is our w? X squared plus 1. So then you differentiate the u dx. So vw x plus 1 into bracket x squared plus 1 du dx. You differentiate x. The derivative of x is what? 1. So everything is equals to, so this implies that the y dx, it implies that the y dx is equals to, so 2x times x, that's 2x squared into bracket x plus 1. 2x squared into bracket x plus 1 plus 1 times x is just x, x into bracket x squared plus 1 plus, so then you have this x plus 1, x squared plus 1, x plus 1, x squared plus 1. So what you're going to do is just open the bracket and you expand through. So you're going to open the bracket now. 2x squared times x, that's 2x raised to the power 3 plus 2x squared times 1, that's 2x squared plus x times x squared, that's x cubed plus x times 1, that's x plus, so you have x times x squared, so we have x raised to the power 3 plus so this is x plus 1, don't forget please. Sorry, this is x squared plus 1 now. So x times x squared, x cubed, x times 1, that's what? X plus 1 times x squared 1 times 1, so that's 1. So what do we have next? So we have, so implies the y dx equals, we have 2x cubed plus x cubed plus another x cubed. So 2x cubed plus x cubed, that's 3x cubed, plus another x cubed, that's what? 4x cubed, plus we have 2x squared plus x squared. That's what do we have there? 2x squared plus x squared. So we have 3x squared plus, so we have x plus x, that's 2x, plus 2x plus, so we have just plus 1 plus 1. So that is the derivative of our product of three functions. So this is where we're going to stop our product theorem. So in the next class, we'll move to quotient theorem. I'll see you in the next class. Drop your question in the comment section, so I'll attend to all of them. I'll see you in the next class.